Okay, so we're looking at problem number 4 from lesson 1-4, properties of real numbers. It says in problem 3, reason and properties were used to show that two expressions are equivalent. This is an example of deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. To show that a statement is not true, find an example for which it is not true. An example showing that the statement is false is a counterexample. You need only one counterexample to prove that a statement is false. So it says deductive reasoning and counterexamples. Is the statement true or false? If it is false, give a counterexample. So here I have real numbers a and b. A times b equals b plus a. Well, their counterexample, if a is 5 and b is 3, 5 times 3 is 15, does not equal 3 plus 5, which is 8. So that's my counterexample. Then it says for all real numbers, so key word here is all real numbers, a, b, and c, a plus b plus c equals b plus a plus c. Well, we know from the properties that we've just been studying or just been reviewing that here the first thing that I've done is just switch them around. So that is commutative property. So a, b goes to b to a, and then I've also regrouped them. So that turns to associative property. So now let's look at guided 4. It says, is each statement in parts A and B true or false? If it is false, give a counterexample. If it is true, use properties of real numbers to show the expression is equivalent. It says for all real numbers j and k. So here I've written it on my whiteboard. J times k equals k plus 0 times j. Well, the first one I might have, let me see. So let's do j times k equals k plus 0 times j. Well, I know here this is an example of identity of addition. I've run out of space. I'm just going to write a little abbreviation. And so if I do that, so that's going to give me k times j. And then here we have commutative property of multiplication. Okay, so we know that that is true just by using our properties. So now let's look at the other one. So here I don't have a property that I can verify this with, because if I use distributive property that we looked at earlier, oops, I know that m times n should give me that. So that means I need a counterexample. I don't have a property that I feel like I can prove this with. So my counterexample, let's say m is equal to 2 and n is equal to 3. Let's see if that works. So if I have 2 times 3 plus 1 equals 2 times 3 plus 1. So I get 4 times 2, which is 8, and I get 6 plus 1, which is 7. Those are not equal. So there's my counterexample. Then it says, is the statement in part A a problem for false for every pair of real numbers a and b? Let's go back to part A. So I have a times b equals b plus a, I think it was. Let me go back and verify. Yes. So I know it's not true for 5 and 3. It might be true that I know for a fact for if a equals 0 and b equals 0, that's true. Let's try for 2. So if a equals 2 and b equals 2, so 2 times 2 equals 2 plus 2, which is 4 plus 4. So it is true for some values of a and b, but just not all real numbers of a and b. So it says for all real numbers a and b, and it's not true for all real numbers. So I hope that this helps.